These storms move relentlessly within Jupiter's other distinct feature, streams of fierce jets that continually circle the planet. Scientists are only beginning to understand what they are and where they come from.
There's a massive eastward flow of material, and that means material's flowing more than 1.5 football fields per second. That's really moving. You don't want to be in that.
29 other belts and zones of varying widths extend outward from there. They are what give Jupiter its characteristic appearance. They move in alternating directions, some eastward, some westward.
They're much smaller scale, the high latitude jets, than the equatorial one. As far as in comparison to Earth, these are massive, super fast, high-speed winds, and yet they're just going back and forth.
The planet's rotation rate has something to do with it. Jupiter generates a lot of energy because it really moves.
So the very nature of the spinning causes Jupiter to not just have one jet stream, but many jet streams going in opposite directions along the planet. And so you can see these zones. So what you have is an exaggerated version of Earth's basic weather pattern.
The spectacular swirls are created in surface clouds where the zones meet. It's believed that the energy ultimately powering this belt phenomenon comes from intense heat deep within. It's not unlike something we see every day.
You boil a pot of water on the stove, it'll start bubbling, and bubbles come up from the bottom and try to get out, trying to circulate that water, that currents around. So it's the same thing inside Jupiter. We have gases and liquids down there that are trying to get the heat out.
There are basic questions, basic pieces of physics to go after, to explain. Massive jets. Shouldn't we be able to explain that?
Earth has just one primary jet stream. It moves eastward, and another major flow that blows westward, the trade winds. Triple that power, and you've got the jet streams of Jupiter.
Totally different from Earth. And yet, I should be careful, not totally different from Earth, just Earth on steroids.
And you ask yourself, wow, if I understood what's going on Jupiter, Earth would be just a piece of cake.
Jupiter's mysteries aren't limited to the planet itself. Some of its most intriguing elements are circling around it.
Jupiter's got several dozen moons that are big enough to be seen. It's probably got a lot more that are too small to be seen with current technology, and no doubt in coming years more will be discovered.
Some of the moons are almost the size of some planets. So really Jupiter is its own little solar system.
Thanks to its incredible gravitational pull, it's sucked in asteroids along with other space debris. For the most part, there is order, but there are some erratic moons in orbit around Jupiter. It's managed chaos.
You can imagine a bunch of runners in a track in their lanes that each runner stays in. They won't collide. It's kind of how celestial mechanics.
Each moon holds its own fascination. 4 of Jupiter's prominent moons were discovered by Galileo. He first observed that they revolved around the planet. They are named for Jupiter, the god's lovers.
The first major moon you come to is Io, which is this very active place with lots of volcanoes. It's almost all the time going off.
Shooting out magma 200 miles into space. Io is a wonder, pockmarked with over 100 volcanoes, some the size of California, which seem to turn themselves on and off. Ganymede is the largest moon in our solar system, 5 times the size of Earth's moon. Callisto is the most heavily cratered. It has clearly taken a beating in its lifetime. Then there's Europa, the ice queen to Jupiter's king. No one knows its makeup for sure.
It looks like a cracked egg. It really looks like the whole thing had liquid water on it at some time. It froze and it cracked. And we believe that these patterns are due to tidal forces that crack it.
As alien as Europa seems, it is smooth and glassy in some spots, hilly in others. In fact, it is remarkably similar to one of Earth's frozen wonderlands.
There is a lake in Antarctica called Lake Vostok that scientists think is an analogy to what we see in Europa. Antarctica has a huge, thick ice crust, and underneath there is this liquid lake, and we think that this may be very similar to the water ice underneath the surface that we see on Europa.
You go down through that crust, go through the ice enough, you'll get liquid water. And we are very convinced that there's liquid water down there. It's the only place that we know of besides the Earth which has liquid water in large bodies that have been there, we believe, for more than 1 million or 2 million years.
And where there's water, could there be life? Jupiter's moon Europa is bursting with secrets. It may even have warm thermal vents deep below its frozen crust.
In fact, an immense ocean, bigger than the Pacific Ocean, worth of liquid water down there that's just sitting there for things to happen to.
The presence of water means one thing. We may not be alone.
I want to go ice fishing on Europa. Cut a hole, put a submersible, look around, see if anything swims up to the camera lens and licks the camera. That's what I want to do.
One scientist is planning just such a fishing trip. At this outdoor lab near Austin, Texas, hopes are hanging on a little robot.
This is designed for exploration in unknown territory, completely unknown territory, and the search for biological life.
It's a deep phreatic thermal explorer, or DepthX for short. Its proving ground right now is a local quarry. And there are big plans for its future.
If everything went according to plan, you would launch around 2016. It would be at Europa by 2018, and by 2019, for certain, we know whether there's life off Earth. That's the game.
DepthX is the brainchild of engineer Bill Stone. He and a team of scientists have staked their reputations on it. They've spent 6 years developing the concept and building the prototype. It's part of an ambitious project that would see it carried into space, sent through 6 miles of ice, and into Europa's ocean.
To divide it down into all the various vehicles, you have a parent vehicle which takes you to orbit around the moon Europa. There will be a lander. It'll land on the ice. Then there's a second stage of the lander which melts its way through 3 to 5 kilometers of